Around 3,800 years ago, in the ancient city of Mari, on the banks of the Euphrates, there was something inside a royal palace that seems completely out of place. Ice. Not a little frost left on the ground after a cold morning. Ice that had been deliberately obtained and stored. The palace belonged to Zimri-Lim, ruler of the kingdom of Mari. Inside this enormous mud brick complex, people were dealing with the same basic problem people still deal with today. Food doesn't last forever. But there was no refrigerator, no freezer, no electric motor quietly humming in the corner. If someone wanted something cold in the middle of a Mesopotamian summer, the cold had to come from somewhere. And if they wanted food to last, they couldn't simply put it behind a door and walk away. They had to solve the problem themselves. But why was ice worth the effort? To answer that, we have to go backward. Long before anyone was storing ice in a palace, humans were already fighting the first enemy of every food supply: time. Imagine you have just returned from a successful hunt. There is far more meat than your family can eat tonight. That sounds like good news. And it is. For about a moment. Because the animal you brought home is not a storage container. It is a clock. The longer the meat remains warm and exposed, the greater the chance that it spoils. The people facing this problem thousands of years ago didn't know about bacteria or fungi. They couldn't see the microscopic organisms changing the food. They only knew what happened next. Fresh food could become unpleasant, then unusable, and sometimes dangerous. So the real challenge was not simply finding food. It was making today's food survive long enough to become tomorrow's food. That became especially important when humans began producing something more valuable than a single meal. A surplus. A successful hunt could provide more meat than one household needed. A good fishing season could produce more fish than a community could eat immediately. A harvest could produce more grain, fruit, or vegetables than anyone could consume before the next season. But a surplus that rots is not really a surplus. It is waste. So the first great question was simple. How do you make food last? One of the simplest answers was to remove something food needs in order to spoil quickly: water. Imagine strips of meat or fish hanging in moving air and sunlight. Slowly, moisture leaves the food, the texture changes, the weight drops, and the conditions become much less favorable for many spoilage organisms. People didn't need to understand microbiology to discover this. They only needed to notice that food treated one way lasted longer than food treated another way. So drying became a practical answer to the problem. Now the hunter had another option: eat everything immediately, or preserve part of it. A fishing community could do the same thing. Instead of allowing a huge catch to become waste, part of it could be dried and kept. A harvest could be dried before storage. And suddenly, food was no longer tied completely to the day it was collected. But drying had a weakness. It depended on the environment. Dry air helped. Sunlight helped. Humidity could work against you. And sometimes the weather simply refused to cooperate. So humans found another way to attack the same problem. Instead of relying entirely on the sun, they used salt. Now imagine a coastal community during a season when fish are everywhere. The boats return with more fish than the households can eat. The problem is not catching food. The problem is keeping it. Salt provided another powerful preservation method. Packing fish or meat in salt draws moisture out and makes the environment less favorable to many organisms responsible for spoilage. And that creates something historically important: time. The fish doesn't have to be eaten today. It can survive long enough to be eaten later. And once food can survive longer than the journey home, something else becomes possible. It can travel. A fisherman can preserve a surplus. A merchant can carry it somewhere else. A community can store it. A ruler can collect it. The preservation of food therefore begins to change more than the kitchen. It changes the relationship between food and distance. Food that lasts longer can move farther. And that matters when societies become larger and more connected. But salt came with a trade-off. The food was preserved partly by being transformed. The same was true of another solution humans developed around fire: smoke. Imagine meat or fish hanging above a slow fire. The fire isn't simply cooking dinner. It is doing something more gradual. Heat removes some moisture. Smoke surrounds the food. Certain compounds in smoke can inhibit some spoilage organisms, and the result is food that can last longer. But there is another consequence. It tastes different. That matters because preservation techniques don't remain purely technical for very long. A method invented because food was in danger of spoiling can become part of a culture's cuisine. Smoked meat, smoked fish, regional traditions built around foods that were once preserved because people had no better way to keep them. But now notice the pattern. Drying works by changing the moisture. Salt works by changing the environment around the food. Smoke combines drying, heat and chemical effects. All of these solutions buy time, but they also change the food, and that creates the next problem. What if you don't want to change the food? What if you want something much closer to fresh? Humans eventually found another answer. And strangely enough, this one involved microorganisms. Fermentation sounds like the opposite of preservation. You are deliberately allowing microorganisms to transform the food. But some microorganisms produce acids, alcohol and other compounds that make the environment hostile to many organisms responsible for spoilage. So instead of trying to eliminate every microorganism, people learned to give certain ones an advantage. Milk could be transformed, vegetables could be fermented, grains could become fermented foods and drinks. Again, the people developing these traditions did not have microscopes. They had observation. This batch worked. That batch didn't. This vessel produced something useful. That one had to be thrown away. Over generations, successful processes became recipes, customs, and traditions. Humans were controlling biological processes they could not see, but fermentation still changed the food. And that brings us to a crucial point in the story. Almost every solution we have seen so far is doing the same basic thing. It makes food last by changing the food or its immediate environment. But what if we could slow the process without transforming the food? What if instead of changing the food, we changed the place where the food lived? People did not need modern refrigeration science to notice that the earth could protect food from extreme temperatures. The surface heats up, the surface cools down, but underground environments can be much more stable. So people began using pits, cellars, caves and underground chambers as storage spaces. The food was no longer sitting directly in the sun. It was surrounded by earth, protected from rapid temperature changes. In the right climate, that could keep certain foods cooler and more stable for longer. This is an important change in the story. Humans were no longer simply preserving the food. They were engineering the environment around it. Shade it, cool it, protect it, control it. But a cellar has a limit. It can be cool without being truly cold. If you wanted to preserve food at much lower temperatures, you needed something colder than the ground. You needed winter itself. You needed ice. And now the problem changes completely. Because preserving food is one thing, preserving cold is another. Winter gives nature a resource that summer cannot. Cold. But winter doesn't last forever. So if cold is useful, the obvious question becomes, can you collect it? Can you store it? Can you still have it when the weather changes? Ancient societies learned to harvest and store ice. In ancient China, historical texts describe the collection and storage of ice for use during warmer periods. And in 18th century BCE Mari, texts associated with the reign of Zimri-Lim provide evidence for an ice storage structure. That evidence needs to be treated carefully. The Mari icehouse was not a refrigerator in the modern sense, and the ice appears to have been associated especially with cooling the king's wine. But that is exactly what makes it interesting. Someone had recognized that cold itself could be treated as a resource. Imagine the practical problem. The ice has to exist before you can collect it. It has to be obtained. It has to be moved. Then it has to survive heat that is constantly trying to destroy it. In other words, humans were no longer just preserving food. They were trying to preserve the thing that could preserve the food. They were learning how to make cold last. Now take that problem into a much hotter environment. Imagine trying to preserve ice through summer in the Iranian plateau. The sun is intense. The air can be extremely hot. And the resource you are trying to protect has exactly one enemy: heat. This is where the yakhchal enters the story. The name is commonly translated as something like ice pit. But a yakhchal was not simply a hole filled with ice. It was a purpose-built cold storage system adapted to its environment. And that is important because the problem has now become more difficult. Mari had access to ice. But what happens when you want to preserve ice in a place where summer is trying to melt it? You cannot stop summer. So you have to design around it. From a distance, a yakhchal can look almost impossible. A huge dome rising out of a dry landscape. But the visible structure is only part of the solution. Much of the storage space is below ground. Thick walls and insulating construction help separate the stored ice from the heat outside. Shading reduces direct exposure to the sun. And in documented Iranian ice-making systems, water could be frozen in shallow basins during the coldest part of the year and then transferred into storage. The details varied from place to place, and not every yakhchal operated in exactly the same way. But the principle is extraordinary. The engineers were not trying to create cold from nothing. They were exploiting the cold that nature already provided. winter became the source. Architecture became the protection. The ground became part of the insulation. And labor connected the whole system. The yakhchal was essentially a way of telling nature, you give us winter now, we will keep part of it until summer. There was no compressor, no refrigerant, no electric motor, no machine actively removing heat the way a modern refrigerator does. Instead, the technology depended on timing, materials, shade, earth, water, and architecture. And that distinction matters. The achievement is not that ancient Persia secretly had refrigerators. It didn't. The achievement is that people developed a system capable of preserving naturally produced ice in a hot environment for later use. For the first time in our story, humans were not merely making food last longer. They were making cold last longer. And that reveals the limit of every solution that came before. Drying depended on weather. Salting depended on salt. Fermentation depended on controlled biological processes. Cellars depended on geography and temperature. Ice depended on winter. And winter was still in charge. So the next question was almost inevitable. What if humans didn't have to wait for winter anymore? For thousands of years, cold storage depended on the environment. If winter produced ice, humans could collect it. If the ground stayed cool, humans could use it. If the climate was dry enough, they could dry food. The environment was not just the background. It was part of the technology. Mechanical refrigeration changed that relationship. Instead of waiting for nature to provide cold, engineers developed systems capable of moving heat out of a space. During the 19th century, mechanical refrigeration advanced through work on artificial cooling, compressors, and refrigerants. At first, these systems were large, expensive, and far from ordinary household appliances. But the principle was revolutionary. Cold no longer had to be borrowed from winter. It could be produced when and where people needed it. And eventually, refrigeration moved from industrial settings into ordinary homes. That was the moment the ancient problem became almost invisible. A family no longer needed a smokehouse, no salt barrel, no cellar, no palace icehouse, no yakhchal, just a machine. Open the door, put the food inside, close it. The clock is still running. You just don't have to watch it anymore. And this is the strange thing about the refrigerator. It feels like the opposite of ancient food preservation, but it is actually the newest version of the same idea. Think about what humans learned along the way. First, they learned that food could be made to last by removing moisture. Then they learned to use salt, then smoke, then controlled fermentation. Then they learned to use cool, protected spaces. Then they learned to collect ice. Then they learned to build structures that could preserve that ice through summer. And finally, they learned to produce cold without waiting for winter. Each solution was different, but everyone was answering the same question. How do we make this last? And that question mattered far beyond the kitchen. A preserved food is food that has been given a future. A farmer can store part of a harvest instead of consuming everything immediately. A fishing community can preserve a surplus instead of watching it become waste. A merchant can move food farther. A ship can carry provisions longer. An army can organize supplies over distance. A settlement can prepare for seasons when fresh food is scarce. Preservation did not single-handedly create cities or empires. History is never that simple. But reliable storage and preservation helped societies coordinate food across time and distance. A problem that begins with one piece of meat can eventually become a problem of trade, logistics, survival, and organization. That is why the history of food preservation is much bigger than food. Now go back to where we started. Mari. Nearly 4,000 years ago, somewhere inside a royal palace, people were protecting ice from the summer heat. At the time, it must have seemed like a practical luxury. Today, you protect cold every time you close a refrigerator door. The technology is completely different, but the logic is strangely familiar. The ancient solution depended on understanding the environment. Harvest cold when it exists. Protect it from heat. Store it carefully. Make it last. The modern solution simply hides all of those steps inside a machine. And that is what makes the refrigerator so easy to take for granted. It did not invent food preservation. It automated an ancient problem. Imagine the refrigerator disappeared tomorrow. No electricity, no freezer, no cold chain. You have food in front of you, and the clock starts ticking. You would suddenly have to think like people did for thousands of years. Should you dry it, salt it, smoke it, ferment it, store it somewhere cool, find ice, build a way to protect that ice? None of these methods is as convenient as opening a refrigerator, but each one represents something remarkable. People looked at a problem they could not see inside. They couldn't see the bacteria. They couldn't see the heat moving through a wall. They couldn't see the microorganisms transforming food. They couldn't see the physics of melting ice. But they could observe. They could experiment. They could remember what worked. They could improve it. And over generations, those observations became technology. So how did people keep food fresh before refrigerators? They didn't have one solution. They built a chain of solutions. They learned to remove water, to use salt, to use smoke, to control fermentation, to use the ground, to capture ice, to preserve cold, and eventually, to make cold on demand. The refrigerator is simply the latest chapter. The real story is much older. It is the story of humans refusing to accept that food had to disappear simply because time was passing. For thousands of years, the problem was the same. Food was valuable. Time was working against it, and humans kept finding ways to make the food last longer than nature intended. That is history solved.